This is the B9 Creator. In addition to having a really cool name, it makes the highest resolution prints of any home 3D printer. This part up here is where everything is printed. This laptop controls it. The way it works is this projector here will project an image up through a window in the bottom here, which will harden resin. It'll harden just a very thin layer of resin, and then the build table will raise up and it will harden another layer of resin. Now there's a lot of black magic about the way this machine works, and one of them is the coating of the vat which contains the resin. This coating is a rubbery substance that's transparent called PDMS. It's normally used for encapsulating solar cells, and it will prevent the cured resin from sticking to the window through which the image is projected. With one caveat, is you can project one slice, one layer of the object through the window, and then the build table will raise up. But before you can make print another layer, this coating needs to see oxygen. So what happens is the entire vat will move to one side and then back again underneath a sweeper, which is basically a squeegee, which causes the resin to be pushed off of the build surface and the air to contact the coating. After a second, the build table is moved back, the resin moves over the window, and another layer can be printed. And all of this is automated, so the machine keeps printing layer after layer until it builds up a three-dimensional object. Here's a closer look at the business end of the machine. This is the build platform, and the three-dimensional object is built upside down on this platform. This is the vat. It's transparent, and it's impossible to tell, but right now it is coated with the PDMS transparent rubber coating. The vat, this will hold the sweeper, which is this little two-part device. It sits right in there. That's the squeegee part of it. That's the squeegee part of it there. The vat moves there, so the image can be transmitted through the PDMS coating to cure a layer. And then it moves back this way, causing the sweeper to squeegee this area clean of resin, so the oxygen can get to the PDMS. They call that letting it breathe. And this is how the build table moves up and down. And that's about it. Those are the working parts of the machine. This part is called the vat, and it's the part of the B9 Creator that holds the resin. I don't know how well you can see it, but there are two sides to the vat. There's this side is raised up just a little bit, and this is where your model will be built. And then there's this transition region that's called the waterfall. And then this is the low side of the vat. And this is the window through which the light is projected. Light is projected up from below through this window to harden the resin. And the build table sits right above this window while the machine is printing. And your 3D model will be built upside down, attached to the build table. And the problem that we're going to deal with right now is you need some way to prevent the resin that the light is curing from adhering to this window. Because if it does, then the whole process isn't going to work. So one of the most critical parts of the process is some coating to prevent anything from sticking to the build table. And in the case of the B9 Creator, that coating is this stuff. It's called SilGuard 184, and it is sold for encapsulating solar cells. It comes as a clear, syrupy kind of liquid that is the main part, and a little bottle of hardener, which is less viscous. And these need to be mixed in a 10-to-1 ratio. 10 parts SilGuard to 1 part hardener. And we'll need about 45 grams to coat the vat. So what I'm going to do is to use 40 grams of SilGuard and 4 grams of the hardener for 44 grams. And I've got a little scale from Harbor Freight, which is a great deal for $10, except for one thing, is once you turn it on, you can weigh something, but after a couple seconds, it's going to turn itself off to save the battery. And that really kind of goes against measuring carefully. It would be nice if the scale was on for more than, say, 2 or 3 seconds. A minute would be a better selection, but there's nothing I can do about that. So I'm going to turn on my scale, and it will zero itself with the weight of the cup. And I'm going to try to pour in quickly as close to 40 grams as I can get. 38. There we go. 41.8. Will have to be close enough. And without wasting any more time, I'm going to try and add 4 grams of hardener. So up to 45 is my shot, what I'm shooting for. 44.67. 45 grams total. Alright. So my scale lasted long enough for that. And I'm going to take a plastic spoon, and I'm going to have to mix this thoroughly. And the instructions say you got to mix it thoroughly for 5 minutes. And try not to get any bubbles in it. Well, I can tell you that there's going to be a lot of bubbles in this stuff after 5 minutes, no matter what you do. So I'm going to concentrate on mixing for the next 5 minutes, and then I'll show you a trick for getting the bubbles out, which is why I'm using such a large cup for such a small amount of SilGuard. So I'll see you in 5 minutes after mixing. So this is how I'm going to get the bubbles out of my SilGuard. So I'm going to put it in this pot, and I got this lid for it, and I got a vacuum pump, and I'm going to pump all the air out of this cooking pot, and any air entrapped in the sill guard is going to expand and bubble up to the top and break. And then I can let the air back in and we'll have all the air bubbles taken out of the sill guard. But that's my sill guard. It's very cloudy. It's white, not transparent at all, and filled with bubbles because I've been mixing it for 5 minutes. And what I'm going to do now is I'm going to place it in the vacuum chamber. What you don't want to do is you don't want to put the thing that lets the air in right above it, because when you let the air back in, the sill guard will be all puffed up like a foam and you'll blow it out of the cup all over your vacuum chamber. So I'm going to move the lid around this way. I can pump the air out of the chamber. And again, I don't know how well you can see that. It's starting to foam and rise, and it's going to almost fill up that big cup. At this point it looks a lot like suds from dishwashing detergent. And it's pretty much filling the cup, and we've got a pretty good vacuum at the moment. So I'm going to pound that, and that's all it takes. The bubbles are gone. I can let the air back in the chamber. And now, there are almost no bubbles at all. Just try to very gently pour my sill guard into the deep end. And I'm going to try not to get any more bubbles in it. It's a nice, slow, even pour. Try to scrape as much as I can out of the cup without making a lot of bubbles. If there's one or two small bubbles in it, at this point they'll probably break and not be a problem. Now I'm gonna tilt the vat. I want to get it to coat up a little bit on all sides of the deep end. Ensuring a good even coating. Again from this point. Okay, so I'm going to let it pile up down here one more time. And then I want it to flow evenly uphill over the waterfall and into the shallow end. And I want to do basically the same thing. Let it pile up at this end. And And then I want the coating a little bit up on the sides. And then on the other side, basically just ensuring everything is covered. Once more back down to this end. Try to get it pretty even. And a little wave of it comes back, flows over the waterfall and down into the deep end, leaving a very even coating and a very smooth curved transition going across the waterfall into the deep end. I'm going to do one more thing, and that is cover this to prevent any dust, insects, whatever. And now I leave that for 48 hours for the sill guard to cure. Here's the upper part of the machine again. This is where the vat will go, and this part, the sweeper, will go here, and this part moves back and forth to move the vat under the sweeper. The sweeper is the little squeegee that makes sure that the vat coating can breathe between exposures. This little hole here is the window, and when this slides over to the other side like that, this window moves over a hole under here, so the light can be projected upwards through the window in the bottom of the vat, and the object is built hanging upside down, adhered to the underside of this build table. And before I install the vat, I'll remove the build table, because we're going to have to do an adjustment with that anyway. Once again, this is the build table. This bolt is all that holds it in. There are 4 alignment tabs on this gold anodized arm, which engage 4 slots on the top of the build table. The build table is made in 2 pieces, and the top and bottom are held together with these 2 screws. And when the screws are taken out, you'll be able to see that the holes in this top part are actually slots, and they allow the level and angle of the build table to be slightly adjustable. And every time you pour a new coating in the vat, it's going to have a slightly different level and a slightly different angle, and you're going to have to do an adjustment to get the build table exactly parallel to the surface of the bottom of the vat. This is the top part, and where those screws go, there are slots, and so if the screws are not tightened, this half of the build plate is free to move around, up, down, to a certain extent, left, right. So what I'm going to do is I'm going to assemble these 2 pieces again, and I'm going to attach it here, but with the 4 screws loose. And what's going to happen is I'm going to lower this down, and it's going to come in contact with the coating in the vat, and then it can slide like that to become level, perfectly aligned, because it's forced into contact with the bottom of the vat. And then what I'm going to do is tighten the screws so that it's locked into that position. Then if I were to just raise it up with the machine, there's a good chance it would pull the coating off the bottom of the vat. So at that point I'll undo the screw here, raise this arm free, and then by hand very gently I can try to rock this plate and get it free without damaging the coating. And then I can screw it onto the arm again. So that's the next thing that's going to happen. So I've reassembled the build table, and the screws are all loose, and I've pulled it down as low as it's going to go this way. So now I can reinstall it on this arm. And I'm ready to go to the next step. The version that I have is version 1.6.0, and at the moment I want to open the utility program, and in my version of the software, the utility program is not where the online instructions say it is. It's under help, and the first choice under help is B9 Creator Terminal Utility. And I get a warning saying that manual operation can damage your coating if you crash something into it, and I'm just going to click yes. And this is the terminal utility that lets me take control of the motors and other functions in the B9 using the laptop. So the first thing that I'll do is click Find Home, and what's going to happen is the build platform will move down and the vat will move over, closing the shutter. Now I'm going to use the switch over at the side of the machine to move the vat back, opening the shutter. And now in the terminal utility program again, I'm going to go to this little box down here that says Send. And I'm going to type in a command, the letter G, a small g, and then I'll press Enter to send that command. And what that does is that will now lower the build table down to the position the machine will always start a build in. Basically with the build table in contact with the coating at the bottom of the vat. So type G, hit Enter, and Enter. And the build table is lowering, and it's going to come in contact with the bottom, with the coating on the bottom of the vat, and the arm will continue down, sliding these screws up in the slots. And what I'm going to do now is just press down firmly on all four corners of the build table, making sure that it's in contact with the bottom of the vat everywhere. And now I'm going to take my tool and I'm going to tighten the 4 Allen screws. And this will lock the build table in this position. So those are kind of a pain to do, but all 4 of the screws are tightened and the build table is flush in contact with the bottom of the vat coating all the way around. So this is very important. Don't forget, take this screw out. Now the build table assembly is separated from this gold colored arm, and I can use the toggle switch on the machine to raise the arm free of the build table. And now that it's free, I can gently try to wiggle and peel that off without damaging the coating at the bottom of the vat. And now this can go back down here. And at this point the machine is mechanically ready to start making a print. The sweeper is not installed. That's one of the last things to be done before actually the machine starts making the print. And the reason for that is because this has to move around another time, and the sweeper here would just be in the way. So I can close up the machine, I can turn off the terminal utility, and I'm ready to start my first print. And this is the software that makes it go. I'll start from the beginning. I've already loaded some STL files, which are the CAD files of the 3-dimensional objects that I want to make. And I will go to this first thing called layout. I'll go to add. I'll pick my first object. This is the STL file to it. I'll click open. And what will happen is it will fail to open the file. Near as I can tell, this is normal. I'll select the same file again, click open, and this time it should succeed. And that tiny little dot there is my object, which was designed in Inventor using inches as the units. And B9 likes to use millimeters, so right now it's converted inches to millimeter, making my part tiny. So I'm going to go over here where it says scale factor, and it has X, Y, and Z axes, and I'm going to enter 25.4 for X, 25.4 for Y, 25.4 for Z. And now I apply changes. And there's the part that I want to print. This rectangle indicating the size of my build area is red because the part is hanging over the sides. It's too big for the build table in this orientation. So I'm going to go here to where it says spin, and I'm going to change that from 0 to 90 and apply changes. And let's move the part over. This is still red because the part is halfway embedded in this plane. If I look up here at position, x0, y0, and z is negative 1.52, meaning that this is sunk about 1.5 millimeters into the plane. So I back off, I make that value 0, and now this is blue and this part raised up, so it is now just flush with the build table surface. I could print just like this, but I'm going to do one other thing. I'm going to move this over so that I can print another object. So I've gone up here to position in the this allows me to adjust its position in X, Y, and Z. I had just previously adjusted Z to bring it up to be flush with this surface, and now I've adjusted Y by making that 14 instead of 0, and that's moved the part over. And now I can go ahead and add another part. It's opening the file. Once again, my part is tiny, so I'll go through basically the same steps. 25.4, and there's the part. There it is. And position, I'm going to change Z from negative 1.5 to 0, and I'm going to change Y from 0 to negative 14. Oops. We move this one to 14 to get it out of the way, and we'll move this one in the other direction. And there we go. We now have the two parts laid out in the build area, and they are ready to be printed or ready to go on to the next level. So I go up here to save. I've already saved a file with this name, mini DF end caps both, and I'll save this under that name. And this is a slightly different file. It's going to tell me that this file exists and ask, do I want to overwrite, and I'm going to click yes. And that's it. I'm done with this part. Now I can go on to the next level, which is slice. What this does is it takes the three-dimensional model and it breaks it up into paper-thin slices, which will be the layers that the machine prints. I go here to Browse. I select my file, mini DF end caps both. I click open. It opens the file. There's a big button down here that says slice. It wants to know where it should save the file when it's through. I'll use the same location, mini DF end caps both. And this time it's going to create a B9 job file with the ending .b9j. So I click save. It asks me, do I want to overwrite? I click yes, and it is now slicing to job. And it'll take a few minutes to do this, so I'll see you in a minute. The computer has now finished the slicing operation, and it gives me this message: finished, slicing completed, all layers sliced, and job file saved. So I can click OK, and I can close this window. Now, if I was making a more complex shape, I could go to File, Edit. I could open the file that I just made, and then, well, I'll do it. Open the file I just made. Now I can click the little wrench and hammer. There are the parts. I can click Enter Support Mode. Tools. This lets me select different supports, which could be put in places where there would be overhangs in my model. This slider here lets me move up, down three-dimensionally through the model. But this would let you move up and down through your three-dimensional model and place supports where they need to be. Just going to close out of this. The last step is print. I'll select my file again, mini DF and caps both. Open. And there's a nice handy checklist here that tells me what needs to be done. Step 1, inspect the printer. Make sure it's plugged in, turned on. Ensure the build table is in place, the vat, and make sure that the sweeper is removed. Make sure that the sweeper is not in place. Step 3, command a reset and positioning of build table to the resin fill level. And at this point, I'm going to change the view a little bit. I'm now clicking command a reset and positioning. It gives a warning that things are going to move. I click yes, and it will now bring everything back to its home positions where things are supposed to begin from. And while it's doing this, I like to put on rubber gloves because things get messy from here. Now what's happened is the build table has moved down at about the level that it's going to be when printing begins. And it's time for me to add resin to the vat. This resin has a red pigment in it which likes to settle out. And if it settles out, your parts will be printed too big. The red pigment is actually there to prevent the light from scattering after it enters the machine. Scattered light causes the machine to print outside the lines, and you don't want that. So this is the first time that we actually get to play with the magic sauce. And as you add, it flows underneath the build table here. And the goal is to add enough resin so that it's in contact with the bottom of the build table all the way around, but does not go over the top of the build table. Because if you let it do that, then things can get messy with resin sloshing around inside the machine. So now that I've added the resin, I can install the sweeper. And there are these little spring clips that hold it in place. Once I have both clips on, I like to pick the sweeper up and let it settle level. So now the vat is filled with resin, the sweeper is installed. I close the hatch and the machine should be ready to begin. I'll click off the last two steps in the checklist. Step 4 was to add material to the vat. Step 5, install the sweeper, which we've done, and now I can hit print. Ejector is warming up, and finally it will move the vat to the print position and project an image of the first layer of the object to be printed, which it's doing right now. It will take a few seconds to expose this layer, and then the entire vat will slide over, allowing the squeegee to clear the build surface or the window of resin, allowing the PDMS layer to breathe. And there it goes. This side is now free of resin. Now the resin is flowed back under the build table and the next layer is being exposed. The machine will continue like this automatically until all layers have been printed. You're looking up at the underside of the B9, and this is the window through which the slices of the part are projected. Right now it's projecting a layer of the part and it's exposing the resin. Any resin exposed to the light will harden. When it's through with this layer, the vat will move to one side, allowing the sweeper to clear resin from the PDMS, which it's doing right now. And then the vat will move back to its original position. Resin can flow in underneath the build table, and it will now project the next layer of the part. Each time it prints a layer, the build table moves up by a very small amount. In this case 75 microns, and it will continue printing layers until all layers of the part are finished. Okay. The machine has now finished making the two parts, and The build table has risen up to make it convenient for me to take it out. So I can open the machine. I grab a little tab here and undo a screw up here. And now I tilt the build table like this and try to let as much of the resin as possible run off back into the vat. Once that's done, alright, there's my build table. These are the parts that I just made, and this is a spatula. And what I'm going to do is again grab the tab and using the spatula as gently as possible separate the parts. This is a trick that I heard about recently for finishing the parts without scratching them. Each part goes in a Ziploc baggie with rubbing alcohol. I give them a quick rinse in alcohol using a squeeze bottle like this, and this alcohol I reuse. I collect it out of this dish, put it back in the squeeze bottle, and then I put just a little bit of fresh clear alcohol in the Ziploc baggie with the parts. So the next step is I fill an ultrasonic cleaner with water, and I'm going to put the parts with their baggies with the alcohol in the ultrasonic cleaner. Try to get some separation between the parts so the waves can find them better. And hit go. Okay, they're done in the ultrasonic. And what I'm going to do is put some warm water in another baggie for each one. I'm going to gently take each part out of its alcohol and drop it in its water baggie. Try to get them separated a little bit in there. And turn the ultrasonic back on. I've got one more baggie of alcohol to set aside for the next parts that I do. So up until now the parts have only been partially cured. They're not completely hard yet. So the final stage is putting them in water, keeping them wet, and putting them under these ultraviolet lights. I think these ultraviolet ovens are for curing fingernails or something, but they work perfectly well for hardening the parts. They should be under here for at least several hours. I usually leave them in all day or overnight. You can't really over harden them. So now it's time for the parts to come out of the ultraviolet bath. And I've got one of these little air pumps. It's for inflating air mattresses and pool toys and stuff. And I can turn this off, unplug this, and plug in the air thing, which is going to get pretty loud. I don't know if you can hear this, but it blows the water off of the parts, just like those hand dryers in the bathroom. And that's it. The part is now hardened, and these can serve as models for creating an RTV rubber mold, and then the final parts, the parts that will actually be used, can be cast from that mold. So I don't need to 3D print parts every time. If I need a lot of parts, I can use this as a model to create a mold and mold more parts. If I need just a few of something, I can just print as many of them as I need.